Keith Rucker here, VintageMachinery.org. So in our last episode of the gear cutting saga we have going on here, we got all the pinion gears cut. We machined out the blanks, and we got all these machined. So the next step here is on a lot of these gears. We're basically going from the small pinion gear to a larger gear, and I've got the larger gear blanks turned and made. That was done in a previous video. You can go back and check that out if you haven't already. But we need to get these machined. But before we do, there's one other little thing we need to do on these gears, and that is we need to put a keyway in these so that we can put a key on the shaft that these are going to run on. So this is I made this where the gear will press up onto the shoulder, but I'm not going to trust that to keep that gear from spinning. I want to put a keyway in there. The originals were not that way. They were just pressed and they held up fine, but I don't know, I just think a keyway is going to be better, so that's what we're going to do. So let's zoom you in over here and talk a little bit about how we're going to go about doing that. So I've decided that I want to use an 1/8 inch key, 1/8 inch wide key. I'm going to use a Woodruff key. So a Woodruff key is this little half moon shaped key like this, and I wanted one that was 1/8 inch wide, mainly because I have an 1/8 inch broach that I can use to do that with, and that's really about the right size for this application anyway. I'm going with a Woodruff key that, if this was a complete circle, it would be a 5/8 inch diameter. Now, because of it's not a full circle, this keyway is not measuring 5/8 across there. But if you look at the keyway cutter that we're going to cut that with, that is a 5/8 inch diameter, 1/8 inch thick. And it is depending on whether you're using the Whitney standard or the American standard, it's either a number 5, I think a Whitney number 5, or a number 405 American is the number for this, but it's a 1/8 inch by 5/8 inch keyway. And that, of course, will go into the shaft. So right here, we're going to come in here, we'll cut that keyway. This Woodruff key will seat down in there, and you'll have a key to go on there. Now on the gears themselves, we'll broach them, and I've got a little push broach, a bushing that'll fit down in there, and we'll go through that process as well. So I think I'm going to start by cutting the Woodruff key holes in these individual shafts they need to go into. Now, one question that comes up when you're doing this is, you're going to come in here on the milling machine, you're going to punch in, but how deep do you need to go? I can measure on the DRO how deep I need to go to get that cut. And it's a difficult measurement to figure out. We know how high we want it to stick out, but because these keys have got a little flat milled on the bottom, it's really hard to get a true diameter on how thick this is right here, because it's not measuring to the outside diameter, it's measuring that flat. But it's easy enough. We can look that information up, and just like we did with a lot of our other stuff before, I pull out my copy of Machinery's Handbook, and in this copy of Machinery's Handbook, there's a whole table here talking about Woodruff keys and these measurements. So, again, I've got a number 5, which is 1/8 inch or 5/8 inch by 1/8 inch right here. And if you look up here, it shows you that measurement D is the depth in the shaft that you need to make. So I'll look over here, measurement D for number 5, and it tells me that needs to be 0.1825 to 0.1875. It gives the minimum and maximum. So that gives me a target to go for. So we'll just set that up on the mill, touch off, and using the DRO, we'll take it in that deep. So I've got my first part mounted up on the mill, and again, I'm using this vise for clamping round stock. I'm going to be honest with you guys, I fully intended to have cut these before I cut my gears, but I got a little bit ahead of myself and forgot to. But fortunately, I'm still able to grip this on that large gear diameter. I've got it positioned where the two teeth are straddling that little slot in there, and it's actually working out just fine. So that's going to shouldn't be any problem. So I've got my cutter set up in here, and the first thing I need to do is we need to get this cutter where it's cutting in the center of the shaft. So I know that this diameter is 5/8, and I've measured that to verify. I know that the thickness of this cutter is 1/8. So what I'm going to do is I'm going to come down and touch off where I'm just barely touching the top of this, and that will become my 0. I'm going to move my cutter out. I'll move it down half of the depth of the 5/8, which will be 5/16. And I also need to move it down 1/2 of the thickness of this cutter. This is 1/8, so that'll be 1/16. You add that together, that's a total of 3/8 or 0.375 inches down that we need to move this. So let's touch that off and get it done. All right, that's touching right there. Now we're going to come up 375 thousandths. 200, 300. That should be the center right there. So now we're going to touch off again on the side of this. Touching right there, so I'm going to 0 my DRO, and we're going to go in 185 thousandths. Nice and slow, no big hurry. Total depth right there, and our keyway is cut. So I got my broaching here, and we're ready to start cutting this keyway. So there's a little bushing that goes down here, and I was lucky. I had a stock bushing in my set that fits this application, so don't have to make one. But we're going to just use the hydraulic press. We'll push this broach through and come back, and we'll have to put a shim behind it and do a second stroke as well. Make sure I got a good straight stroke going on this, so I'm just going to release the pressure a little bit and go back down now. Put the spacer and shim behind that and repeat a second time. Got the keyways cut now in the 2 of the gears, and I've still got to do the 3rd gear here, but we're going to make that out of a different material, so I haven't got the blank ready. But got the Woodruff key slots in these, And I've got everything laid out now. When I took these apart, I paid particular attention to make sure I marked the gear with the shafts. I got 3 dots, 2 dots, and 1 dot on both of these. And that's just to help me remember which one goes on where. So what we're going to do now is, first thing I'm going to do is I'm going to get some, probably some acetone or something. I'm going to clean these gears up really, really good. Get all the oil residue, whatever, off of them. Then I'm going to put a little bit of Loctite on these, and we will press them together with the keys in. And we're actually going to cut the gears on the shaft that they're going to be turning on. I just figured that will give us the most absolute truest running gear that we can get by actually cutting them on the shaft they're going to run on. So I'm going to go clean these up, and we'll be back and we'll get these pressed together. Next thing we want to do now that we've got all these cleaned up is I want to go ahead and put these Woodruff keys in. And these are fairly tight fits. I got a little copper hammer, and we'll just drive those down to depth. That looks good. Same thing on this shaft. That looks good. This will go together just like that. But before I do that, I'm going to put some Loctite on it, and then we will probably have to press that on. I'm over at the press, and first thing I'm going to do is just put a little Loctite in here, and I'm going to take a little brush and kind of brush that around, get a good coating on there. That looks good. And I'm just going to probably manually press this down. Right there. So we got those 2 gears pressed on, and they're keyed. We're going to let that Loctite cure for about 10 or 15 minutes while I'm setting up the milling machine over here to start cutting this first gear. I've got my big gear on here that I need to cut 50 teeth on. That'll be the next one we do. And to do that, I got to change plates out here. So we've had this one set up to cut 12. To cut 50, I need to be able, one for every index, it's 16/20th of a revolution. So it won't even be a full revolution, just 16/20ths. So I need to put a plate on here that has 20 holes in it. And this plate here does not have that. So I've got another plate. So we're going to go ahead and pull this apart and swap the plates out. A little clip here. It holds the sucker arms in place. So you can come off. And now there's 3 screws. need to set my scepter arm to 16/20, so I'm going to start here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to loosen this right here. We're going to slide this around to here so that we can go between those 2 points. All right, let's put the rest of this back together now. Put it back on. There we go. All right, so we go one, just around to right there. This will come around. And so on. Start at the top. Just like the other gears that I did, I'm going to do this in 2 passes, and I've calculated how deep my cutter needs to go, which is 157 thousandths of an inch. But I'm only going to cut, I think, 100 thousandths from the first pass. We'll get a measurement over the pins to get an accurate, make sure that we're right on with money, and then we'll feed in the total amount that's left and finish it up. So right now, what I want to do is I want to start the mill up. Put it back in gear. There we go. I'll start the mill up, and we're going to raise it up until the cutter touches off. All right, it touched right there. We're going to raise up the table 100 thousandths to 1 full circle on the indicator. Right there. I don't think I showed this on the last video, but this mill has a stop on it. I've stopped it manually where I want it to come to a stop at, and now I'm just going to tighten this up, and when it comes in, it will knock this feed lever into the neutral position, so I don't have to worry about stopping it manually. All right, we should be ready to start cutting here. Got my dividing head set up, my height is set. So we're gonna go ahead and make our first pass. So just like before, we're going to measure these over the pins to figure out where we need to be. So I got 2 pins, and I've already talked about the size these pins need to be. In this case, it needs to be 120 thousandths. And if you want some more information on that, you can go to my previous video where I talk more about that. And I've measured these with the micrometer, but just to keep it simple for the screen here, you know, I've measured this, and what I've got is a 3.840, 841, somewhere right along in there. So I know from my target that I want to be 3.721. So 3.840 we'll call it, minus 3.721, which is my target. 119 thousandths, divide that by 2. I need to go down about 59.5 thousandths for the final pass. So we'll get over here and make that adjustment. Have our indicator set up again, and we're going to go up 60 thousandths. 50 and 10 more right there. Let's make another trip around the block. So we got the 50-tooth gear all cut now. I did some measurements, measuring over the pins again. Everything looks good. This gear will mesh up with this pinion, and it looks like it's a good fit. So we've just got a few more to cut. So I've got this 40-tooth 16 pitch, and then I have already turned a blank out of Delrin for the gear that was made out of the composite material. So the original gear, you know, is some type of phenolic type material, Bakelite, something along those lines. Probably will never know exactly for sure. But to replace this one, we're going to use this Delrin, which I did a good bit of looking and kind of doing some research, looking at the strength of this material, and I think it's going to be plenty strong enough for this final gear. And the reason they used that was for noise reduction, to have that fastest turning gear where it wasn't metal. You had something that would dampen the vibrations in the blower. So anyway, we're going to go ahead and get set up to cut these last 2 gears. I'll probably do those off camera. You've seen the process now. It's all pretty much the same. So we'll be back to show you the final goods here when we get through. So I think we're all done here, guys. We got all of 6 of the gears that had to be cut. The 3 small pinion gears, the 3 larger gears here. I've done some quick inspections just over the pins, measurements over the pins. Everything looks like it checks out fine. So I'm real happy with how these gears have turned out. Real happy with how well my dividing head functioned throughout all of it. And these are now all, should be ready to go back together. So that'll make another wrap, guys. Glad you stayed tuned to watch all my gear making. If you missed some of the earlier videos, you can go back and see the entire process. I'll try to get this put up as a playlist on YouTube, where you can just watch the whole series in order if you haven't already seen the other episodes. So all in all, I'm very happy. You know, when we cut this Delrin gear here, I did get a little bit of fuzz on the back. We'll have to go in there and clean that up just a little bit, probably with a little knife or something. Just where that cutter came out, it just kind of fuzzed a little bit. no big deal. But these are ready to go back together. I'm gonna come back in as a separate video and we'll show the assembly of all these and getting it back together and getting the blower, the Blacksmith blower, hooked back up out here at the museum. And maybe we'll even do a little bit on blacksmithing and kind of introduce you guys to the blacksmith shop in the Museum Historic Village while we're doing that. So something to look forward to. We'll try to get that up as quick as we can. And thank you guys, as always, for watching. We'll talk to you later.